our red marrow converts into yellow marrow pretty quick. The number of stem cells decline very fast in our life. In our 30s, we have lost more than 90% of our red marrow, which corresponds to a sharp decline in the number of stem cells. So your balance in your health is a balance between the speed at which you lose cells and the speed at which you can replace the cells that are being lost. There's a point in our 30s where we no longer have enough stem cells in circulation to offset cellular loss. And that's the point in your life when you discover, if it has not happened yet, it will come. I can tell you it happens to everybody. You discover you're not Superman or you're not Wonder Woman. You start to injure yourself, and it's not repairing like it used to be when you were 10. You don't have enough stem cells in circulation to repair, and the cells you're losing, you cannot offset that cellular loss. And then start a slow, very slow, cumulative deficit in all your tissues. And where you will experience that deficit depends on your genetics, your past injuries, your lifestyle, exposure to environmental toxin, your diet. All kinds of factors will determine what is the weak spot in you, and that's likely where the problem will show up. So I proposed this whole concept, this understanding of disease formation based on stem cells about 10 years ago. And in this article, I was saying there's a way to test if that understanding of disease formation is real. Let's go and count the number of stem cells in people who have developed these so-called age-related disease, and let's compare that to people of the same age that are healthy. And now there are many of these studies. Here's one on diabetes. If you count the number of stem cells in the bloodstream of people who are at different stages in the development of diabetes, you have a straight line. The further they are in diabetes, the fewer stem cells they have in circulation. Same thing here in kidney failure. To the left, you get healthy people, and the three other columns to the right, these are people at various stages of kidney failure. And not only can you see that they have much fewer stem cells in circulation, but the number goes down as the disease progresses. And if you do a graph of stem cells with kidney function, you get a straight line. You get the same thing with erectile function, erectile dysfunction. To the right, people who complain of poor erectile function. To the left, control. You bring the average to the axis, and you can see about half of the number of stem cells in circulation compared to people with normal erectile function. You take a graph of erectile function and number of stem cells, you get a straight line. Erectile function has a lot to do with vascular health. There are many measures of vascular health. Let's take the most common, blood pressure. People with hypertension, half the number of stem cells in circulation compared to healthy people. Same thing with COPD, lung disease. Same thing with Crohn's disease, ulcerative colitis. Same things with heart disease. Same thing with Alzheimer's, Parkinson, lupus, arthritis. The list keeps going as more and more, this is arthritis, as more research is coming out. So I just wanted to show you all that stuff to really draw just one simple conclusion. Just like I say, your health is determined by your immune system, and how strong your immune system is. Your health in terms of your ability to stay healthy and repair is entirely determined by how many stem cells you have in your bloodstream to repair and offset the normal cellular loss that happens with life. Which is to me probably, and for you as biohackers, as healthy people or simply moving in life, I was going to say aging, we don't have to say it, nobody youths, really. So in this process of aging, there's a phenomenon that is happening that touches everybody, and it's the fact that, so the first two tells us more stem cells in circulation means that you can repair better. The third one is that if you happen to have fewer stem cells in circulation, then you are at risk for developing any one of those so-called age-related diseases. And here's what that means. In the original study about repair, they do this process, bone marrow transplant from a male donor, and then they do an injury, let's say, heart attack, Parkinson, everything that we talked about. And then you look at the new cells in the area of the repair, and you can identify that they have the Y chromosome, meaning that they came from the bone marrow. That's how they did these studies. So in some of these studies, you're left at the end of the study with a number of mice, extra mice in your study, and typically, I've been in the lab, you keep them as pets. And 3, 4, 5, 6, 8 months later, the question comes, well, let me go and look at the rest of the animal to see what I find. And the whole picture emerged. You see cells with the Y chromosome everywhere in the body, but different number of cells depending on the tissue. The liver repairs faster than the heart slower than the liver, and then the lung, and so on. So the question was, do we see this in humans? And there's one circumstance when you can see this in humans. It's women with leukemia who got a bone marrow treatment receiving bone marrow transplant from a male compatible donor. So now you have a woman whose body is all double X chromosomes, but the stem cells now have the Y chromosome. So scientists went back into the bank of tissue biopsies at the time of the autopsy when one such woman had passed away, a year, 5, 10, 15 years after bone marrow transplant. And as they go across all these tissues, the whole picture emerged. Something that we sort of always knew intuitively, but never had really any data. And it's the fact that you get a new liver every 2-3 years, a new lung every 4 or 5 years, new pancreas 4 or 5 years, new lining of the intestine 5 days, new muscle 9 years, half of a new heart every 25 years. Everything in the body is constantly in this process of turnover. When you're 60 years old, you don't have a 60-year-old liver. You don't have a 60-year-old lung. Everything is renewing. There's a real consequence to this process. It's great because honestly, thinking that you're living with a 60-year-old liver, meaning that our health would just decline so fast. So it's great news. We have a process of renewal. We have seasons in the body.